Yeah, I'll be talking about socio-ecological resilience to soil erosion in East Africa, more specifically our interdisciplinary approach. So we have an interdisciplinary team of multiple scientists from different institutions. So a short introduction. So I recognize time is short, so I won't go too much into detail because most of it was covered this morning anyway by Professor Palm. But basically, to quote David Montgomery, like there's no base for survival of a society if soils slide off the land faster than they are produced. So in context of the UN Sustainable Development Goals, this links to all of them. This links to food security. The hunger map definitely shows East Africa and Sub-Saharan Africa as a hotspot of hunger in the world still. But it also, for example, links to energy. So there's siltation of reservoirs, which decreases the energy production of those reservoirs. And it's predicted that with current climate change, there will be more runoff in East Africa, which will increase the potential for erosion in those areas. So our approach is interdisciplinary. So we have three big bases. So first we will try to define the problem, and then we will try to identify pathways to change, and then facilitating actions. The first big base we have to do is sort of look at the environmental and human history. So basically human-environment interactions in East Africa and how they led to increased soil erosion and land degradation. And then we can look at how that land degradation impacts community resilience and how communities cope with that, if they can find ways to reduce land degradation, or if they are sort of trapped in these or locked in these patterns where they will increasingly have to sort of degrade the environment. And this is mostly done by human geographers and also psychologists. They will look at identity, they will look at behaviors which may sort of force them to behave in a certain way. And then lastly, if they identified sort of barriers to change, they can also think about how can we move around those barriers, or how can we remove those barriers and sort of facilitate action. And one sort of step in this is co-design of sustainable solutions. So a quick background to land degradation in East Africa. So it's really complex, and the history of East Africa is, the human history of East Africa is the oldest in the world because it's basically where humans originated. But you have a really natural high vulnerability to soil erosion because you have a very distinct topography. You have a semi-arid climate, and then really important, you have a disequilibrium vegetation, which basically means because there's a lot of variation in rainfall, there's no climax vegetation. So one year you have a lot of vegetation, you have a lot of rain, so the vegetation can grow, but the other year you will have droughts, and then so the vegetation cannot really buffer for years with a lot of rain. And you also have, in a lot of area, fragile soils. So indigenous systems, they sort of co-evolved with these variabilities, and they adapted by systems of intercropping or shifting cultivation, nomadic pastoralism. But then those colonial alterations, which sort of altered the human-environment relations into this sort of Western system of really large-scale agriculture. And it wasn't like you got sort of scale mismatches between sort of the really diverse East African environment and then the really large-scale Western system of agriculture, but you also had displacement, coercion, which basically led to a decrease in the sort of social capital of East African communities. And then the post-independence nation states, they were built on these colonial borders and principles of modernity. So they were basically continuing the same processes. And so like the current social economic system in East Africa there's a lot of poverty and population increase. So some authors argue that East Africa is a Malthusian trap, but why is there no escape? So we know from certain areas in East Africa, people are able to adapt to population increase by sustainably increasing their agricultural output, but other regions don't seem able to do it, so they tend to degrade the environment and mine their resources. But poverty isn't only economic or economic notion of it. It's also has a lot to do with land rights and land access, but also there's government and political representation. So this is sort of a really theoretical framework. Land degradation isn't only sort of a natural capital thing, it's also a social or socio-economic capital thing. So it often starts with erosion of indigenous social capital, and then when the social capital is really low, people really don't really have the knowledge to manage their soils, and there will be sort of an erosion of the natural capital. So we have three sort of evidence bases, and we were working mostly in the Lake Manyara catchment in Tanzania. So the first big thing we did was sort of land cover change mapping. So we used Landsat images. So between 1988 and 2016, there was a massive increase in agricultural land, mostly monocrops of maize. So from 10% to 25%, and that was mostly by a decrease in bushland and sort of grasslands. And then we used a RUSLA, revised universal soil loss equation, to sort of pinpoint areas where this potentially leads to an increase in surface erosion risk. And we combined that with gully density mapping. So what you can see in a lot of areas which are red here, there's also an increase in gully densities. So this particular one is 8 meters deep, and it originated in less than 10 years. So what happens on the ground? So we went to a couple of sites in Tanzania, and one really big factor is the loss of vegetation. So it's probably the most important factor, and this can happen to multiple systems. So it can happen through overgrazing, deforestation, sometimes also just drought. But this basically exposes the soil, and it also decreases organic matter in the soil. So organic matter is linked to soil stability. So this is aggregate stability. So in the degraded rangelands, you can see the aggregate stability is really low, while in some of the conservation agriculture or natural forests, the aggregate stability is really high, and this is always linked to organic matter. So when the rain falls, the aggregates tend to sort of explode, and these form a crust, and this crust is sort of really difficult to it doesn't really allow infiltration. So instead of infiltrating in the soil, the water will tend to run off, which is demonstrated in this graph. So these are conservation agriculture and pasture. So they have quite high levels of infiltration, while these ones are rangelands, and they have quite low levels of infiltration. So once the water runs off, it leads to overland flow, and this overland flow tends to take all the eroded soil with it. So you get big chunks of sheet erosion, which you actually can see. This one is like 2 or 3 centimeters of sheet erosion, and the topsoil is really high in nutrients and organic matter. So this removes most of them. The overland flow converges in natural depressions, but also in trackways, cattle trackways or roads or whatever, and it starts to incise in the landscape, and then you get gully formation. And then this is sort of a positive feedback, because it increases the connectivity. So while previous, when you had soil erosion, it got deposited in the hill slope itself, now it really rapidly just gets washed downstream. And this is sort of a positive feedback because there's less water available on site. There's also less nutrients, less organic matter. So it's much more difficult for the vegetation to recover naturally. So there will be less vegetation, so there will be even more erosion and so on. So it's a good question to ask, is the system at a tipping point? We did some geochemical fingerprinting from a small reservoir. We used some trace elements. So in total we used over 20, but I'll just demonstrate a couple of them. So titanium, for example, is, in general, we could correlate that to more erosion happening, while silica is sort of a good tracer for subsurface erosion. Magnesia then it's more produced in the lakes itself, so it's a good indicator for autogenic production. So in general, if we in the lake, we can see that from 1980 until now, there's a general increase in soil erosion. But what's really interesting is that there's sort of fluctuations between topsoil and subsoil. So we see a general increase in topsoil, which is due to a decrease in vegetation cover. And then 1997, there was a big drought, which was followed by the 1998 El Nino. And this sort of pushed the system towards this really massively gullied system. And then you can see this. This is like more or less more subsoil, and then currently you have like a lot of soil erosion, but it's both from subsoil and topsoil. So runoff is not only a problem, in that area. It's a basin-wide problem. So these flood peaks, when there's less infiltration in the soil, the flood peaks will get much higher. And then they destroy roads, they cut off communities from the market. It's a really big problem in Tanzania. And then, the sediments are washed downstream. So this is Lake Manyara, which is a really vulnerable ecosystem. So it's an alkaline lake. It has over 2 million lesser flamingos, but it's threatened by sedimentation. And this sort of adds further complexity to the problem because it also threatens biodiversity, but also human health. It threatens the economy and livelihoods. But overgrazing and land cover change, they are actually human problems. So it's not really, we tend to look at it as soil scientists from an environmental perspective, but actually it's a human change. So are these communities actually locked into this sort of negative spiral of degradation? So there's a lot of big increase in population, but also the climate is changing. There's also a lot of sedentarization of nomadic pastoralists. The government is changing, and there's a lot of privatization of common lands, which are suddenly given to big corporations, especially the most productive lands. So it's good to sort of identify the barriers to change. And for a lot of pastoral communities, there's a high cultural importance of cattle, and it's also sort of a bank account basically for leaner times. So that it's very difficult to say you have to destock, because if you say to a Maasai, for example, you have to reduce your cattle from 100 to 50, it's like saying to us, you can't earn 2,000 pounds anymore, you have to earn 1,000. It's basically the same, so they will tend to disagree with that. It's also, this is sort of linked to tragedy of the commons, but it's not really tragedy of the commons, it's more of a tragedy of open access because of the degradation of these traditional institutions which govern the land. Now it's like centralized government, but they can't really seem to figure out how to manage these common lands anymore, and it's all about who will take the responsibility or who will get sort of the power to do it. this is sort of both good and bad, but there's a lot of harmony in the community. But if, for example, if people see somebody cutting a tree which is not allowed, they will not say anything because they will, they want to keep the harmony in the community. They don't really want to, they prefer the community over the ecosystem, basically. And there's also a lack of skill or a lack of education to diversify their livelihood. On the other hand, there are also a lot of opportunities. So for example, education is valued, so people really want to learn. The communities are also really cohesive, which means that if you get land management practices going, cohesive communities tend to be more willing to go through with them. And this is also both a blessing and a curse in that the land degradation is happening really fast. So people can sort of see it happening. So if it happens in 10 years, a person can recognize that it actually poses a real threat to them and to the community. So they will be more willing to change. So we organized a couple of exploratory meetings with the community, which sort of aim to co-design pathways to change. There were a lot of demonstrating our vision of what is happening in the environment, what is going wrong, but also what they think is going wrong. And we are also doing we're trying out some new tools to support behavior change. So one of them is infographics. So Gary Marks, he's a graphic designer. He designed some infographics which we translated to Swahili, and they're distributed to local schools and local government agencies. But there's also some more community work going on. And in the end, it's all about, the community's challenged. So there was this one farmer who said, I'm glad that you came here, but we see scientists coming all the time, and for us, nothing happens. Everything stays the same. So why are you different? And that's actually a good question because, scientific funding is usually 5 years or something, and it's not enough time to actually see anything happening. So what we try to do is sort of get the ball rolling and then let the communities, give the communities the chance to develop it themselves. So we had 3 big bases for that. So the first thing we did is restoration plots. So with that, we actually just want to demonstrate rotational grazing. So if you have a grazing plan, or the lands can regenerate quite well by themselves. And the other big part is knowledge exchange. So there's some really successful farmers which practice intercropping and mulching, but we want to bring them in contact with maybe pastoralists which are transitioning from a pastoral existence to agricultural existence. And these bottom-up, these grassroots, they're very important, but it's not enough. So, yeah. I'll finish, sorry. So yeah, like farmers, they need to adjust to the demands of population increase and commercialization by building upon but not abandoning their existing social capital. But it's not enough. They need to integrate it into nested institutions in regional and national government. So the other big part we've been doing is sort of trying to let them navigate the Tanzanian law by co-designing village-specific bylaws. And with that, we hope to sort of, let them have the capacity to adapt to land degradation. So yeah, we've been working with multiple institutions in multiple countries, and we've been funded by GCRF and NERC. And thank you for listening to me.
There's one very, very quick question for Maarten.
Maarten, fascinating talk. Thank you very much. Gully erosion is a real problem wherever you find it, and particularly where you have very limited resources to deploy in controlling it. I'm just wondering if you have any thoughts about how you remediate some of those gullies and stop the water moving off those degraded lands.
Yeah, I think the most important thing to do is to decrease the runoff coming from upland to the gullies, because if that remains high, you can't really do anything. And yeah, the other thing is try to. There's some good examples from Ethiopia where they use check dams and to try to reduce the flow. But in the end, it's all about sort of managing upstream, managing the land cover, so less, like there's more infiltration instead of runoff. I think that's the only actual solution to gully erosion.